Hello calculus students, here we are with the introduction to limits. Limits are a tricky idea, but it's basically considering the behavior of a function as the independent variable approaches a value, what's happening to the value of the function, the dependent variable. So in this case, what's the behavior of the function of fx equals 2x minus 1 as x becomes closer to 2? So we're going to look at a bunch of values that are close to 2. Right. Just by doing on the bottom here. Get all our values by doing things like f of 2.1, boom, 3.2, and f of 2.01, 3.02, and f of 2. Go to our options, rounding. We don't want 2 decimal places, we want 15. Okay, now we can do f of 1.99. How about f of 1.999? There we go. And so those are our values from demonstration. So what value of f is the value of f of 2 as x gets closer and closer to the value of 2? So we write this out as, what is the limit as x gets closer to 2 of 2x minus 1? And we're seeing in either direction, looks like it's getting closer to 3. Okay, let's try another question. Now here's a new function. Consider the favorite f of x equals square root of 2x, and let's put these values in. Okay, I got that right here. There's the graph. And let's try a bunch of those values. So, f of 2.1, 2.05, f of 2.01, oh, again, I gotta change my options. Rounding to 15 decimal places. There you go. Let's try f of 1.9. Or f of 1.99. Okay. There we go. And there's our values for that. Take the square root. So, let's put that over here. Now let's ask the next question then. What's the limit as x approaches 2 of the square root of 2x? Looks like from points to the right of 2 we're getting closer to 2, and for the left of 2 we're getting closer to 2. So we get 2 there. Now it seems like the limit is the same thing as just plugging things in. Like if we put 2 in for here, you get square root 2 times 2 is square root of 4 is 2. Same thing in the first problem. Square limit as x goes 2 of 2x minus 1, 2 times 2 minus 1 is 4 minus 1 is 3. But this is where the plugging in doesn't work so well, because now if I try to figure out what the limit of 3 is, and I put 3 into here, 3 squared minus 9 is 0, 3 minus 3 is 0. Ouch, we get 0 over 0, undefined. In fact, we call it indeterminate. So we're going to use a graph then to figure out what this is exactly. So let's look at number 3 here. It's this one. And let's look at these values that are being asked for. And this time 2, so you get a sense of what we're getting closer to here. I'm actually going to plot the point. So I'm going to plot the point 2.9, comma, f of 2.9. It shows up to that point. See, we're a little to the left of the point there. There's B. So let's try 2.99, comma, f of 2.99. And we're getting closer. to something. Remember, let's get our rounding back up to 15 here. There we go. Now let's look at f of 2.999. So 2.999 comma f of 2.999. Yeah. And D is getting even closer. Oopsie, it didn't plot it. I think it's because, no, that should have been point D. Here, maybe I'll go like this. There we go. Plots. There's D. Now let's come from the other direction. 3.1, comma, f of 3.1. There's E on the other side now, the point we're trying to get closer to. Let's try 3.01, comma, f of 3.01. Again, we're getting closer. The numbers are getting smaller. Now let's look at 3.001, comma, f of 3.001. There. So the numbers kept getting smaller and getting closer and closer to 6, and they approach 6 from below over here. So let's take a picture of that. Boom. Okay. Put them over here now. And we can answer this question now. What is this limit? So the limit as x goes to 3 of x squared minus 9 over x minus 3, if you just try and substitute in, we get 0 over 0. That's undeterminate. But here it looks from either direction that we're getting closer and closer and closer to 6. And that's kind of clear when you see that this reduces down to x minus 3 times x plus 3 over x minus 3. It reduces down to x plus 3. So the limit as x goes to 3 of x plus 3, we can see how that's equal to 6. But these two things are not exactly the same, are they? This is undefined at x equals 3. So you start seeing there's a difference here. F of 3 in this scenario is actually undefined. The limit as x goes to 3 of f of x, though, is very much defined as 6, because we're talking about the behavior of the function as you get close to that point. In fact, if we look back at the GeoGebra file, and if I actually ask it to put in the point 3 comma f of 3, it says no can do, undefined, undefined. All right, now let's work on this fence problem. Okay, a fence is to be built around a square flower garden. So let's get up our square flower garden here. There we go. How close to 10 feet must the length of each side of the box be in order for a total length of the fencing material to be between 39.96 and 10.04 feet? So how close to 10 feet? So in other words, we've got 10 feet on each side here, 10, 10, 10, and 10. And the total perimeter is 40. But to get the total perimeter between these two, if we want the perimeter between 30.96 and 40.04, what does each side have to be? Well, recall that perimeter does equal 4 times any of the one sides. So 39.96 is less than 4s is less than 40.04. Let's divide through by 4. And you get 10.01 on this side is less than s. And over here then, 39.96 divided by that is 9.99. Let's just check that. 39.96 divided by 4. Yeah, 9.99. So basically, the sides must be within 0.01 of 10 in order to get the area within 0.04, or the total length, total perimeter within 0.04 or 40 feet. And that's going to give us an idea later on when we talk about epsilon delta proofs. But now let's get back to this again. Use your calculator to graph this function. Let's see what happens with f of x equals square root of x plus 1 minus 1. So, let's see what we got here. Let's look at it in GeoGebra. And you can look at it on your calculator. And let's see what's going on in the picture here. Here's our graph. And notice if we try and ask it what's going on at 1, right, because that is the magic number, what's happening as x becomes close to 0 from either direction, and if we put in 0, comma, f of 0, and let's not put O in, put in 0, comma, f of 0, it says it's undefined. Well, that's a problem. So let's get some points on either side then. Let's see what happens at something close to 0, like 0.001, comma, f of 0.001. Okay? Yeah. And we get this point B. And again, let's crank up our options here to get a lot more decimal places. There we go. And it looks like 0.4999. And if we go to the little left of 1, let's look at negative 0.00001. Let's make it really small, comma, f of negative 0.00001. Yeah, got enough O's in there? Yeah. And we get this point, which is again rounding, and it's a little above 5. But you can see how we're getting closer and closer and closer to 0.5. And let's try and see how this can happen. Why we get a half for an answer on this. First of all, let me just cut and paste the picture here, graphics via clipboard. That was from before, sorry. Let's instead, here, let's get our picture back. And I do want to get these points that we did over here before. I need this guy. Oh gosh. I need this guy. And we need to cut out something from here. Kink. Grab these guys. There you go. And also let's get our picture. Come on. What's it doing here? Oh joy, here we go. Still calculating something here. It's maddening. Let's put that away. Maybe that'll help. No. Oh, it's maddening. Okay, so what happened with this here is we try to see what happened by just substituting in. And when you do the limit here, come. So if we look at the limit as x goes to 0 of the square root of x plus 1 minus 1 all over x, if you just try and sub in, you're going to get 0 divided by 0. But if we look here, we can see it's getting closer and closer and closer to a half. How can this be? Well, as I said, if you just try and do limits all the time by subbing in, sometimes that works, sometimes that doesn't. In this case, you get 1 minus 1 over 0, you get 0 over 0. We call that indeterminate. 0 divided by 0 is not 0, and technically it's undefined, and furthermore we call it indeterminate, because it could be equal to any number. You have not determined it yet. So we're going to practice this skill in upcoming chapters about how to deal with a limit like this. But we're going to put a little trick in here called multiplying by the conjugate of the numerator, and you actually get the limit as x goes to 0 then of x plus 1 minus 1 over x times all that stuff. This becomes the limit as x goes to 0 of x all over x times all that junk. So you get the limit as x goes to 0 of 1 all over. Now what was in that side of that junk there? It was the square root of x plus 1 plus 1. Now when we evaluate the limit and put 0 in, you see we get 1 over the square root of 1 plus 1. We get 1 over 1 plus 1, or 1/2. So there's a proof of why that limit is 1/2. Even though the function itself is undefined at 0, it seems to be getting closer and closer and closer to something. Flange out.